Hello ladies and gentlemen, it's Mike here at Game from Scratch, and today we're doing something a little different for this channel. Today we are talking about hardware, and outside of my laptop reviews, I almost never do hardware related stuff because frankly, there's not much reason for people to send me hardware. There's not a lot of game development related hardware devices out there, but today I have one. I was sent one of these, by the way, thank you Clockwork for sending this to me. It is called the Clockwork GameShell. This is an emulation device, but the reason why I'm talking about it on this channel is it's also very much aimed at indie game developers. So if you ever wanted your own build it yourself, yes, you literally start from scratch on this thing, build it yourself device that you can then develop games for, this could be perfect for you. So we're going to walk through it. First, we're going to look at the device really quickly, and then I'm going to show you my breakdown of it from when I built this thing myself. By the way, I am completely unhandy, so if you're scared about building something yourself, hell, the fact that I managed to put this thing together, you can do so yourself. So don't worry about it too much. There are a couple of gotchas in the instructions, but I do focus those in my build guide, which I will link down below. So if you want to build your own, it's not hard at all. Don't be scared off by that. And then we're going to do hands-on with the device, show you what the menus and the installed hardware and game engines and such are out of the box. And of course, since this is my channel, you're probably wondering, hey, can I run Godot on this thing? And yes, you can, spoiler alert. So the last half of this video, we're going to show you how to get a Godot game running on the Clockwork GameShell. But on top of that, the same instructions would work for getting Godot running on any Raspberry Pi device. So even if you're not particularly interested in this device, stick around. You can see how you can install Godot on other Raspberry Pi powered devices. So that is it. We are there at their website over here. It is available at clockworkpi.com. We are looking at the game shell. I will link the Amazon link down below, so if you want to pick one up yourself, also that helps the channel if you do that. You can see this guy is powered by a quad-core A7 CPU, Mali GPU, Wi-Fi, Bluetooth. It's got a built-in 16 gigabyte micro SD card. You can change your own device in there. It's built in a number of different modules. You put them together yourself. We'll see that in just a second. My only real complaint on it, the battery is a little on the tiny side, and I did run into some software problems. Now, the software problems is where we get to the next part of why this thing would probably be interesting to this channel, is it is built on an open source version of Clockwork OS, which is derived from Debian 9. So that is the base. You can, right out of the box, run Pico 8, Love 2D, Pygame, Phaser games, and so on very smoothly. So this guy is developed and aimed at game developer and, of course, retro gamers. So you've got RetroArch in there. We'll see that in action in a few minutes as well. So if you are interested, it is open source, so you can go over to Clockwork Pi on GitHub. I will link this as well. Things like the warehouse, the launcher, various different pieces, the extensions they made to the kernel, the Bluetooth, the loader, all of the stuff that are required to make this guy work are available open source, mostly under the GPL3 license, which it works for this kind of stuff anyway. So if you're interested in getting into the guts behind this guy, all of the repositories are there. All of the things that make Clockwork Pi are available and open source. But as I mentioned earlier on, this guy is something you have to build yourself. Now, I was actually kind of shocked when they shipped me this thing, the general quality of what you got. So as you can see here again, you get a quad-core A7 GPU, you get 2-channel stereo speakers, a 2.7-inch screen. The resolution is, I think it was 320 by 240. I'll get to that in the next part when I do the Godot bit. But it is one of the more common, 300 by 240, which was like the resolution of the day back in the 16-bit era, and why they went with that. So if you're looking at emulating retro games, it's a good screen resolution for that. Again, it comes with 16 gigabytes out of the box, but you can just use your own card if you want to have more in there. Their custom OS is, again, built on Debian. It ships in a box, pretty good quality to be honest. I was actually shocked again at the quality of the shipping materials, and it comes in a number of vac pack pieces. So basically you are building each little module. So each one of these holds a piece of the game. So you're building these little sets together. So you've got one for the input, you've got one for the screen, you got one for the main board, and then you've got other little things like the stereo speakers that go at the bottom and so on. The instructions are the IKEA picture-esque type instructions. There was one gotcha, was when you're putting together the screen speaker. By the way, these are all a little distorted. You click in, you get higher resolution details. So there, 320 by 240 is the resolution of the screen. The instructions make it a little confusing here in terms of bending the screen. So if you are putting this together, I do recommend you come in here and read the guide on it. But you see, you're really basically just building together a bunch of different pieces. And I think I got a picture of them all together. So here you've got your screen behind that. You've got your CPU and main board. You got your input on top. Your battery goes underneath. There is your speaker setup, and then you've got the cables routing to hook all these things together. And then you kind of put it all together, and this is the point where you finally get it all hooked together, and you press that power button. You're like, what did I screw up? And in my case, actually, amazingly enough, I didn't screw up anything, but there are a couple snags to be aware of that made things a little bit confusing. So the first step was creating the display module. You do actually have to bend the cable backwards. It's confusing, and it doesn't seem like something you want to do, but the cable doesn't line up. So in this picture, they show you it coming out, but in reality, you actually have to do this bend right here. They have a couple spots where the plastic mounting, so when you first get it, so going back up here, you'll see everything is on these plastic mount points, and a couple of these mount points, unfortunately, are also the entrance points where you have to feed cables in, so you have to like narrow down. So get a modeling knife or something so that when you're cutting the edges where these cables have to slide in, you're going to want to make sure none of the plastic trim is still there to rub against the cable. So that is another thing I ran into there. And then the biggest thing, and the reason why this was delayed for quite a bit, because I got this guy back in November, put it together over the holidays, then I kind of broke the operating system. And I didn't break the operating system. They broke the operating system. So something to be aware of. If you want to stay cutting edge, if you want to do the updates on it, with the Clockwork OS 0.5 update, there was some problems with it. It broke the driver. I couldn't get the X11 display manager to run on it for quite a while. I had to do a custom build of the GPU driver to get things going in. So I have some experience with Linux. I'm not a daily Linux user. If you use Linux all the time, you're not going to have any issues with this at all. But if you're an absolute hobbyist, don't upgrade the OS on your own. It's one of those things, wait for either like a flashed stable release or just leave it as it came out of the factory. So that was the one thing that I ran into. They shipped an OS update that had some game-breaking problems in it, and it took me a long time to work around those things. So if you're not technical, do be a little bit careful there. All right, so now we're gonna go hands-on with the device. So let's take a quick hands-on with the device. I'm going to give you an idea of what the menus are like, what the screens look like, and all that kind of stuff. Now, unfortunately, I'm capturing this from using my phone. I don't have the video out hardware on this thing, so I can't do a good screen recording, so the video quality is going to suffer a little bit. But as you can see, pretty straightforward navigation and menu. In your settings here, there's one very important setting if you're going to do any performance-related code, is what you want to come into is the settings, head on down, and set up the GPU driver. So you see here, there's two options. There's a software rendering and the experimental Lima driver. You definitely want to make sure that the hardware accelerated Lima driver is enabled. Otherwise, you can see there's some stuff pre-installed here. We've got Pico 8 and TIC 80. Pico 8 does require you to have a license for it to work. TIC 80 is basically a tiny computer built in, so you can see the kind of stuff you can do. You can actually do development directly on the device. There are some demos that you can run with and work from. Pretty straightforward on the whole experience. You can see some of the examples that you can work with from TIC 80. This is typical of that whole virtualized computing space. There's a ton of stuff out there for these kind of things, but like I said, it comes with a couple of them installed out of the box. And yeah, you can see it running right here. Now, obviously, the video quality isn't illustrating what you actually see on screen. Your screen result will look better than what you're seeing in this capture. Unfortunately, again, just the nature of the way I captured things. There's also a couple cool things going on, such as the warehouse here. They actually do game jams for this device, and the warehouse is kind of where they share the results of those game jams. And so if you want to, check out some of the other people's work that they've done on their own Clockwork GameShell, you can do so this way. We've also got a couple of games installed out of the box. We've got Love installed. Love is a Lua-based 2D game. I've done a game engine. I've done a full tutorial series on this guy. So if you want, you've got the Love runtime already installed. You can SSH in and type your code directly and run it. The runtime is there for you. And here you can see one of the examples running. The audio is obviously quite muted, so hopefully that didn't blow your ears out. But you can see this is the kind of stuff that you can write using Love, which again, the Love runtime is built in out of the box. So you don't have to do anything setup-wise to get there. You basically just go in and start writing your code. And then we've got, finally, the ability to run retro games. So obviously, any handheld worth its salt is going to have emulators pre-installed. And as you can see, you've got most of the major devices out there. You've got Game Gear, Genesis, Coleco. I think Nintendo 64 is on there. There's Amiga, PlayStation, and so on. I'm going to just illustrate you one thing running, and that's with the Mega Drive. And I'm running Shadowrun. Now, Shadowrun, if you do not know, is the single best game ever made for a 16-bit console. Yes, I'm actually going to stand by that. I absolutely love this game, and it's one of the few games I actually go back in time and still play. And you'll notice it's actually running pretty much identical to original hardware. So you get the performance out of this that you would expect. If you do not have that Lehman driver enabled, by the way, though, not so much. So your performance is going to suffer a bit. But even on the screen form factor, the game is very playable. When text is up, you can read it. The performance is what you would expect it to be. It plays exactly like what the version does on my Genesis, which I still have in my garage just so that I can play this particular game. So by the way, if you have never checked out Shadowrun for the Sega Genesis, you definitely need to do so. It's an amazing game. I love this game. So yeah, you've got RetroArch built in there, so you have a number of consoles ready for you. Obviously, you don't have ROMs on there. That part isn't completely legal, so you're gonna have to provide your own ROMs, but you've got everything that you would expect emulation-wise. Now, this being my channel, of course some of you are going to be interested in wondering if you can run Godot on this thing. And the answer is yes, you can, but there are some gotchas to go through. So, of course, I'm going to go through those gotchas with you. This is going to show you the process of running a Godot application on your GameShell device. Now, there are a couple of steps here, and the first one, obviously, is Godot itself. What you see in front of you, a very simple application. I wrote Godot 3.1.2. It just moves the icon around when we press the cursor keys, goes back when we press or exits the application when we hit the escape key. This is mostly just to illustrate the settings that are required to get the GameShell working with the Godot engine. Now, there are a couple of steps here. First off, you're going to want to go into the project settings, and there are a few things to be aware of. The first one, obviously, is your display. The display on this guy is 320 by 240 pixels. So you're going to want to set those guys right there. You're going to probably also want to set it to always on top, if not by default. And then I set it to the 2D mode with keep width as my settings. If not, you get some weird stretching kind of artifacts going on. You want to make sure that this is set, and then it will show up right on the display. Now, the next thing you're going to run into is the splash screen isn't going to look right. That's because the default splash screen that ships with Godot is bigger than 320 by 240 and doesn't get shrunk down. It gets clipped. So what you're going to want to do if you want to have a splash screen that works is switch out that image to something that has been resized for 320 by 240 or smaller, or just basically set it to off and you're good to go. So that's sort of some of the display stuff you've got going, and really that's it for project configuration. Otherwise, what you need to do is export out your project. Now, I did a video on this just a few days ago on how to install and manage export templates. So if you don't know how to do that yet, check that video out. It will show you the process. But then when you've got that installed, you want to go ahead and create a Linux X11 Runnable. And this is, you're making a Raspberry Pi target here, but this will work just fine. But the key thing here that you're going to want to do is set 64 bits to off. We're creating a 32-bit binary here, and the other key thing, and this is the most important part, is we need to set a custom template. So you see here, I've got a release template installed. In order to get one of those, there are two sources for it. First off, there's this guy, AP Youngblood, who has created and managed his own. He's doing the compilation process for you, and he's providing them as binary files. So we've got a release and a debug version. I download this zip file right here. You extract it out, and that is the file that I specified. There's also the option of the FRT project. Now, the FRT is a Godot platform for targeting single board computers, basically Raspberry Pi devices. This is the same deal. You can compile it yourself, but really what you want to probably do is download his binaries, pre-compiled binaries, and use them instead. Either approach will work. Sometimes one works better than the other. Sometimes the vice versa. It kind of depends on the current state of the templates and of Godot. But for this example, I'm using the ones provided right here. If you're interested in either of these details, it's actually this forum post over on the Clockwork forum that has 99% of the details about compiling for the Godot game engine. So do be sure to check that out. So now that we're ready to go, we're going to go ahead back to the Godot game engine. All right, come here, Godot. All right, and then go ahead and export out your project. It's going to create a file. I'm going to go ahead with clockworkpi.x86. The only other key thing you want to do here is turn off export with debug. And then click save, and it'll create it for you. I've already actually done so, so I'm good with that. And now that we have a binary to work with, we need to send it up to our device. And there's a couple ways of doing it. The easiest way, especially on Windows, is probably to install an FTP client like FileZilla. I'm just going to go ahead here and launch FileZilla. Now we need the IP address of our device in order to make this work. You'll notice if you go to Tiny Cloud on the GameShell and just load that up, you get all the information you need, your username, your password, and the IP address we're working with. And we just enter those in here. So 192, get out of my way, text box. 168.0.39 in my case. And our username is CPI for Clockwork Pi, and our password is CPI, and we're going to be connecting on port 22. And we'll go ahead, do a quick connect, say, yeah, sure, we're fine with that key. And then boom, we are now connected to our device. Now we're going to see one of the problems with the Clockwork Pi is unfortunately it is 2.4 gigahertz wireless only. So this can be a little bit slow. So I'm going to head on over here, go to games. I made a folder already called Mic, and you're going to see it's empty. What we're going to do is pick our executable. So clockworkpi.x86, that file extension means absolutely nothing, by the way, and PCK file. You want to grab those two and drop them on your remote device. And this can take an intermittent amount of time. You never get huge speeds on it, and a lot of it depends on how close you are to your router. We all know the joys of 2.4 gigahertz wireless, especially in a city like Toronto where there are more wireless connection points than there are people. So your speeds are going to vary, but it's never exceedingly fast. So I'm going to pause this while it continues to do the upload. Okay, so it took about 3 minutes and now we're done. The PCK file and the x86 file have both been uploaded. Now we need to kind of geek out in the Linux side of things for a few seconds. Now, if you're using Windows, the easiest way to do this is use any SSH client you've got. Something like Putty would work, P-U-T-T-Y. But if you're running Windows 10, you probably have an SSH client built in. This is kind of a way of remotely connecting to a Linux machine using the terminal across. And if you load up PowerShell right now, let me just zoom that in so you can see that better. Let's just maximize this guy. All right, so what we want to do now is connect to our Clockwork Pi. And all we got to do is go SSH and then 192.16. Actually, let's do the full thing. So CPI at 192.168.0.39. So we're saying connect as the user CPI to that IP address using the SSH protocol. And if you're running on Linux or Mac, you'll have SSH out of the box. So don't worry about that. Then we're just going to do a CPI as our password. And then boom, there you go. We're connected to our Clockwork device. This is just like using the terminal on any Mac or Linux device. Same kind of process. If you don't know how to do this stuff, welcome to the rabbit hole. You got some learning ahead of you. But first thing we're going to do now is go into the games folder. Like so, you're going to notice we have the mic directory that I made, so we're just going to switch into the mic directory. And then inside of that, we've got our two files, the PCK file, which is the data file for our game, and then the x86 file, which is the binary we want to run. The thing is, with Linux, you need to set executable bits on machines. So see here, we go and look. So this is LS, or list structure, I think LS stands for. I'm actually not sure what list but basically this is list. So list all the files in the current directory, and we want to show their attributes. And what we're seeing here is, see, there's this D here for a directory, and there's X bits for executables, but our x86 file does not have that bit set. So we want to go ahead and set that, and you change attributes using a command called chmod. So chmod plus X, we're assigning the executable bit, and then we're doing it to clockpi x86, like so. So now that is an executable binary. So now we can run it on our device. Now let's head on back over to our device, and let's go back. All right, so now what we want to do is go over to, by the way, once you have your game defined, you can create a shortcut so that it shows up in this top level menu. But I'm just going to go in here to utilities. We're going to load up Bean. And this is like a file explorer. Give it a sec to load. And boom, 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 boom. Now we're going to go to the bottom here. We've got the file browser. We're going to go ahead and select that. And then I'm going to use the A button for back, 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 back. And then we're going to locate our games folder like so. And then hit the B button for forward. And then we're going to go to mic. And then there. And then here I'm going to hit the menu button on the x86. And it's going to bring up a list. And since we set that executable bit, it has the option for execute. If execute is not shown, that is because it is not an executable. Once it is, go ahead and hit the B button, and it will run our game. And here you see, first off, there's the truncating I was talking about. It's clipping down the image because it's too big. And then here is our guy running. As we press buttons, you're going to see the label mixes things up. Our A, B are all mapped to weird keys, which is part of why I did that. And then we've got the menu button also maps as the escape key. So I hit a menu button, and it's going to say escape pressed, and then it's going to exit our application. But there you go. You just saw a Godot application running on the GameShell. So that's also, by the way, the exact same process you will use for deploying to a Raspberry Pi device or something else from Godot. So a twofer there if you so wish. So yeah, you can definitely run Godot games on the GameShell, but there is a bit of a process, and it is honestly a little bit fragile. So just do be aware of that fact. So ladies and gentlemen, that is it. That is the GameShell. It's a really cool device. It's, as I mentioned earlier on, it is available up on Amazon. It's $139 US right now. I've seen in the month or two since I've had it that it's been on a couple of different sales, so that price does vary. You'll actually notice that the Amazon price is cheaper than on the GameShell website, so if you want to buy it, you're probably best picking it up from Amazon. Now, again, I gotta warn you right up front, this guy is aimed more at game devs, hackers, enthusiasts, and so on. So if you're a little afraid of the idea of using command line Linux, or you're terrified of building something yourself, this may not be the right device for you. But if those sound interesting to you, if you already like or enjoy working with Linux, or you want to learn how to work with Linux, it's a great device. I'm actually quite impressed with the build quality overall, even after an idiot like myself put it together. So don't be too afraid of building it yourself. I managed to do it, and me. Now, again, I don't have a lot of experience with these kind of devices. I've had some, cheap emulation devices like $40 or $50, and you kind of got what you paid for. But there might be a much better recommendation out there. I don't work a lot with Raspberry Pi. I've always been interested in it, but I've never really jumped too far into that world. So if any of you guys have a recommendation along the same lines for other people, please do let me know in the comments down below. And do you have a GameShell? If you do, how was your experience putting it together, and what do you think of it overall? All right, that's it. I will talk to you all later. Goodbye.